Good morning, ladies. Good to see everybody here today. So we're still working on continuity that we started yesterday, and we're to this graphic here, and you may not be able to see very well. I'm not sure what kind of resolution you have on yours, but this is a hole right here in the graph, and here's a point right up here. And so here we have, this is sort of just an exercise in telling why the following graphs is not continuous at x equals c, and we're going to be using the language we came up at the front of the note card. Remember the three conditions? Remember the three conditions of continuity?
Yeah.
So if we look at this one, why is this thing continuous here?
Yes. Or no.
No? Okay. So let's go ahead and explain this. So no, it should be obvious that the thing is not continuous, that there's a hole right there. So just common sense tells you the thing's not continuous, right? So let's go ahead but figure how to articulate it in terms of what we had up front. So does f of, it says that x equals c, so this could be c, right? Does f of c exist?
Yes, just not on the line.
Yes, so f of c exists. So meets condition 1. 2, does the limit as x approaches c of f of x exist? Does that exist? Does the limit exist?
It's not on the line.
Hey, look, remember what a limit is. Hannah really made a good effort. She explained that we came from the left, we get this, and we came from the right. Are we coming up to the same place when we go right? Does the limit exist?
Yes.
Yes, exists. Now, are these two things the same thing? Is the value of this f of c, is f of c equal to the limit as x approaches c of f of x? Are they equal? No, they are not equal. So I'm going to put this. Therefore, x is not continuous at x equals c. Okay. Now here on graph 2, we have a hole sitting right there. You see that on your paper?
Yeah.
It's a little hole. And so, condition 1, does f of c exist?
No.
F of c does not exist. I'll put does not exist. And so have we found enough work for continuity here?
Yes.
Yes, we have. Therefore,
X is not
f
continuous at x equals c.
f of x is, if I spell is, continuous at x is equal to c. And I kind of miswrote this here too. I want to put f of x is not continuous over here. So f of x is not continuous at x equals c. Here, and what it is, you go down the list, and the first condition that doesn't work, it's over. You have proven that doesn't exist. But to prove it does exist, you have to actually go through all three conditions. Yes, you do. But one will take you off the track. So on number 3 here, condition one, and we're talking about at C right here, just like we were talking about C here. Does f of C exist?
Yes.
Okay, exists. So that's condition one. Condition two, does the limit as x approaches C of f of x exist?
No.
No. So it does not exist. So can we make a conclusion right now?
Yeah.
So therefore,
F of x does not continuous at x equals.
okay, is not continuous. If I could spell continuous, that'd be nice. At x equals C. See, maybe I'm coming down on that sugar crash a little bit early. What do you think? No? Think I'm okay still?
Kaylee said she had sugar crash.
Oh, did you? But I know I'm kind of joking about it, but that's actually an issue for this class period, isn't it? Yeah. Okay. So I want you to go ahead and play with these 4 and 5. Is that what you have on your paper?
Yeah.
I want you to go work on those, and we'll kind of go over those together in a few minutes. How's that? And while you do that, I have some more package for you. More package. Easy, more package. You want to take an extra one for Emily? She's going to be here tomorrow.
Well, we have tournament tomorrow. So
Oh, that's right, not here anyway tomorrow.
Okay.
Good
Can I have
idea.
another packet?
You want another packet? That's supposed to be part of it. Oh, that's the homework one. What I'm going to do Friday, since I'm probably not going to be here because I told you I'm going to be in jury, right?
Jury duty.
Jury duty, Friday. What I'm going to do is I'm going to give you one of those. Remember I had the one I gave you, that homework assignment that had the QR code, like you work on that? I'm going to give you one of those you can work on, and then you can probably do that over the weekend. So that's what I plan to do for Friday. So we're not going to be handling new material from the packet on Friday. At least that's the plan for now.
What are you going to be doing tomorrow? Just more notes?
Tomorrow, we're gonna continue to work on continuity, maybe, but we might start on intermediate value theorem,
Okay.
which is no card 6.
So we just need to watch the video.
Yeah, probably. That'd probably be it. And what's happened since we've had class, pretty much, we've had at least one person gone every day, right? And so it's really been on my mind anyway that, hey, these videos, we want to have stuff on there that covers the material. Speaking of volleyball, how did volleyball go yesterday?
Good one.
Was it pretty easy?
Yeah.
Pretty easy, okay. So where did you go last night?
Maybank.
Oh, Maybank, okay. I remember Maybank where they had the highway going straight through before they bypassed on 175. So that's how long ago I remember. Okay. So let's go look at number 4. And so let's write down the conditions. 1, does f of x exist at -3? So f of -3 exists, and I also like to put down and is equal to what?
Five.
5. 2, does the limit as x approaches -3 of f of x exist? Does that exist? Does the limit as x approaches -3 of f of x exist or does not exist?
Yes.
Why do you know? Because this one incorporates what? This one has which limits? Okay, I'll tell you. This one includes left hand and right hand limits. And since it's the same function rule, right, it's going to be the same. So exists, and what is that equal to? Let's plug in -3. So -3 squared is 9 minus 2 is equals 7. So 3, does f of -3 equal limit as x approaches -3 of f of x? Are they equal? No, they're not. So you can write it like this, and if it is, you can leave it like this. If they're the same, you can just leave it like that. If it isn't, what can you do? Slash. So therefore, f of x is int, I'll say isn't, I'll abbreviate contraction, big contraction, isn't continuous at x equals -3.
Sure, do you have to find out the first one?
Condition 1,
Yeah.
because right here on this line, okay, what this tells us here, this one tells us this is the function rule where x is not equal to -3. So this is the function rule for every place except where x equals 5. I mean where x equals -3. So at x equals -3, this is what it is. For x does not equal -3, this is the rule. So that's how I found it. And yeah, I'm glad you asked the question, because this notation is, the piecewise function notation like this is brand new, isn't it?
Yeah.
And so, since you asked that question, it shows me that you're not entirely used to it yet.
If there's not a solid number, like see how there's like a 6 on the next one, so that would mean that would exist. The first one would exist. F of 3.
Yeah, so it means that f of 3 is equal to 6. So it's this whole thing over again, but you're saying f of 3 exists and equals 6.
So that's where your black dot would be on the graph.
This is your black dot, yes. In fact, you might even write this down. Okay, black dot. So that's your black dot right there at x equals 6. I mean, at x equals 3, y equals 6. And this one is going to be a hole unless what? Unless this one should happen to fill that hole, right? Because this one by itself has a hole, right? And it's going to have a hole where x equals 3. You can see that we have a non-removable.
So we're just seeing if that the one that fills in the hole matches with the first one to fill in the hole, so it's going straight.
Exactly. Okay, so what Hannah's describing is right now, with all those arguments, that's like an analytical argument, right? But Hannah is relating that to the graphical thing, graphically what it does. So there's analytically what writing the rules are, right? But graphically it's actually seeing that thing fill that hole. And so again, since last year I've talked about p-vein, right? Here we have graphically and matching the analytically is what we're doing. So if you can visualize what graphically is happening in conjunction with your analysis, then you're coming to a more comprehensive mathematical understanding of what's really going on. So that's what
it makes more sense.
Yeah. So you asked a good question. I got to put a star on the paper. Okay. So 2 we have here 2 limit as x approaches what is it, 3 of f of x exists and is equal to 6. Okay, let's check that, because if you factored the top, you would just have x plus 6 left, right?
Yeah.
And if you plug in 3 for x,
It's x plus, yeah, x plus.
you get
X plus 3 on top.
you get x plus 3, so that'd be 3 plus 3,
Yeah.
so that would check out. So what it is, now we write this we'll put down f of 3 equals limit as x approaches 3 of f of x. Is that a true statement?
Yes.
Yes. So therefore, f of x is continuous at x equals 3. Is this making some sense?
Yes.
Pretty well? Carmen, you doing pretty well with this? Think? Okay, yeah. She gives me the thumbs. What about Elizabeth? You okay on this? Everybody's okay. Kaylee, you okay? She's fluttering the hand a little bit. But you understand what Hannah's question was, though? You didn't understand it? Okay, let's go back here. Because that's really a crux here. Because what happens is, on number 4, for instance, we have this function right here. We have this function x squared minus 2, right? And we're trying to evaluate for x equals -3, what's happening here. So at x equals -3 is right here. And so the function is going to go something like this. So the function rule comes like this, but not right at exactly -3. So what it is, there's a hole right here. Okay, then the thing comes down like this, and then goes up like this, right? So that's what's happening. So you see, Kaylee, this is what we're talking about. We're talking about this function here with this hole, because that does not apply, right? It's telling you that there's a gap right there at x equals -3. You see that? But then they're saying at x equals -3, that's going to be Now the value of the limit is going to be 7, but right here, there's a point here at 5. So there's a point right here, the function's defined, but is that point, does it fill in that hole there? No, it does not. And so that's why we're not continuous. Whereas on this one here, we have, that's going to be like x plus 3. So the thing is going to look like this, but what happens at x equals 3? Right? So that's what this is looking like. And so we have to look, is this thing going to fill in the hole here? Yes, it is, because the limit is 6. Okay, the limit is 6, because that's the location. And also, the value of the function itself, which is right here, this one right here, that's going to fill in that hole. So the one on the left does not fill in the hole. This one here does fill in the hole. So that's why this one is continuous, but this one on the left is not. Is that better? Okay. All right. Anybody else? Okay. Let's go on here. Okay, what I want you to do is look at what if they were both labeled 6? So I decided relabel the number 6A and 6B. So I want you to go ahead and look at that right there. And actually look at just do 6A. Just do 6A first, okay? Is it just me, or does it seem like the class period's going by pretty quickly today? It doesn't? It's going by slowly? So you feel like... Pardon me?
Are we about to be out of here?
Well, we actually are, yeah, I think 53, so we have about 8 minutes of class left.
That's close enough. That's close enough.
Discuss with
I thought you were just like kidding me.
and other business.
I thought 6 a.m.
You guys are looking like a good class, all right. Ready to start going over this one here?
Yeah.
Okay. All right. So for 6A, condition 1, we put down, we're at x equals 2, so we're going to say f of 2, does that exist?
Yes.
How do you know that it exists? There's one thing that tells you it exists. How do you know the thing exists?
Is it equals to?
Okay, it's this thing right here, where it says less than or equal to.
Yeah, the bottom.
So that's how you know it
When I
exists.
solved it, it was -1, and -1 is less than.
And
Good job, Emma.
is equal to, so if we plug in 2 for this, we'd have it, right?
Yeah, you get -1.
So -1. And
That
so
makes the statement true.
2, the limit, and here we don't know the limit yet, right, do we? Because we've got to match up those two. So I'm going to put the limit as x approaches 2 from the left of f of x equals question mark, I put here, right, question mark, limit as what? As x approaches 2 from the right side of f of x. So we have this all set up, don't we? So we already have our left side limit because we found it right here, didn't we?
Yes.
That's going to be the same as this. So we know on the left side we have -1 because that's what was plugged in here. And the right side we don't have that yet, but we know that's at 2. So that's going to be 2 squared minus 2 times 2, right? Well, what are we going to have on the right side here? -1 equals,
Zero.
0. So the limit as x approaches 2 of f of x what? Does not exist. So therefore what?
It's not continuous.
Okay, so f of x is not continuous at x equals 2. Okay, so we've disproven after condition. Now we have just a couple minutes of class left. Here's what I want you to do. I want you to work on number 6.
It scares me.
Yeah, number 6 has two, right?
Yeah.
Has 2 things we're looking at. So what it is, this is a piecewise function that's kind of like a 3-headed monster.
Yeah.
Isn't
I
that?
think we're gonna need you to explain it.
It's a 3-headed monster, and so so do what you can, but we'll start tack on the 3-headed monster tomorrow. How's that?
Sounds great.
And that's on page 72 here. But what this means is we have 2 things to evaluate. So we're going to have to do this for -1 and for +1. For x equals -1 and x equals +1. So that's what we're going to do. And we know that f of -1 exists because of this, and we know that f of 1 exists because of this. So we'll just leave it right there. Got about 2 minutes of class left.